Welcome back to another episode of Data Deep Dive. Today, we're exploring the fascinating world of Rdf, Sparql, and Datalog, and how they shape our understanding of graph-like data structures. Whether you're a seasoned data engineer or just curious about data organization and querying, there's something here for everyone. So grab your headphones and let's dive in. Let's start with RDF, which stands for Resource Description Framework. It's a standard for encoding information in a way that's both machine-readable and friendly for humans. RDF uses a structure known as triples, consisting of a subject, predicate, and object. For example, you might encounter a triple that states, Lucy is born in Idaho. Here, Lucy is the subject, born in is the predicate, and Idaho is the object. RDF can be expressed in various formats, like RDF XML or Turtle N3. While RDF XML can be a bit verbose and cluttered, many prefer Turtle N3 for its readability. Tools like Apache Jena can help convert between these formats, making it easier to work with RDF data. To illustrate RDF XML syntax, imagine a location structure that includes Idaho as a state within the United States, which is part of North America. This hierarchical representation clarifies the relationships between different entities. A key aspect of RDF is its use of URIs for predicates instead of simple strings. This means that if two datasets use the term within, they can still be differentiated by their unique URIs. This feature allows for smooth data integration without conflicts, which is a significant advantage when combining datasets from various sources. Next, let's talk about Sparql, the query language designed for RDF data. Pronounced Sparql, Sparql stands for Sparql Protocol and RDF Query Language. It allows users to write queries to retrieve and manipulate data stored in RDF format. For instance, if we want to find people who have moved from the United States to Europe, Sparql makes this query quite concise. Its syntax is straightforward and similar to other query languages like Cypher. You can even use prefixes to simplify your queries, making them easier to read and write. One of the standout features of Sparql is that it treats properties and edges in the same way. This means you can query both relationships and attributes using similar syntax, which is a powerful tool for data exploration. Now let's shift our focus to Datalog, another query language that operates on a different paradigm. Datalog is known for its rule-based approach. Instead of sticking to the traditional triple structure, it uses predicates in a format like predicate, subject, object. This allows for more complex queries that can build upon existing rules. For example, if we want to determine if Lucy migrated from the United States to Europe, we can define rules that recursively check relationships. This approach not only offers powerful capabilities, but also encourages a different way of thinking about data queries. While it may not be as convenient for one-off queries, its ability to handle complex relationships makes it a valuable tool in the data toolbox. Taking a step back, let's consider the broader context of data models. Historically, data was often represented in a hierarchical model, which worked well for certain applications, but struggled with many-to-many relationships. The relational model emerged as a solution, but as data needs evolved, new non-relational databases, referred to as NoSQL, began to take shape. These NoSQL databases can be broadly categorized into two types: document databases and graph databases. Document databases are designed for self-contained documents where relationships between documents are less common. In contrast, graph databases excel in scenarios where everything is potentially related to everything else. Each of these models, document, relational, and graph, has its strengths and weaknesses. While you can represent graph data in a relational database, it often leads to awkward implementations. That's why different systems exist for different purposes, allowing developers to choose the best fit for their specific application requirements. An interesting aspect to note is that many modern databases don't enforce a strict schema, which can make adapting to changing requirements easier. However, it's essential to recognize that your application likely still operates under some implicit structure, whether it's enforced at the time of writing or handled during data retrieval. As we wrap up our exploration of these data models and query languages, it's worth mentioning that there are numerous query languages out there, each with its unique syntax and capabilities. From SQL to MongoDB's aggregation pipeline, the landscape is rich and varied. In conclusion, understanding the nuances of Rdf, Sparql, and Datalog can significantly enhance how we work with data. Each of these tools offers unique advantages for different types of data relationships and queries. As we navigate the evolving world of data, it's crucial to select the right model and query language that best fits our needs. Thank you for joining us today on Data Deep Dive. If you enjoyed this episode, be sure to subscribe and tune in next time as we explore more exciting topics in the world of data. Until then, keep diving deep.